So here it is. You'll find the estimator at heatpumpestimator.com. Basically what we've done here is designed a tool that can develop a concept level view of whether a heat pump may be suitable for a given application. It's not trying to solve the exact size, the exact capacity, rather trying to provide indicative values of what size and what capacity you should consider in a conversation with an engineer, an advisory group, or an industry expert. When you first come to the page, what you'll find is it'll bring you to a page once you've made an account that says Start Wizard. If we click on Start Wizard, it'll bring up looking for some information on where your existing site is. Now, we couldn't map every city of Australia, so what we've done is we've said pick your nearest location. So in my case, for my example, I'm going to choose Melbourne, but you can see there are preloaded cities here to consider. If we pick Melbourne, it'll work off a weather profile embedded in the back for Melbourne. Now that weather profile is seasonal. It has a representative day from every season, and also will have just an annual average and a set of design conditions for the heat pump. So a design dry bulb temperature specifically for winter before sizing the peak of the heat pump. If we look at heating load profiles, now we did develop some standard load profiles. There are 7 of these. Office, aquatic centre, meat processing plant, dairy factory, manufacturing plant, hotel and hospital. Now, when you do click these, you'll see that this changes down here. Now, this is just showing you what that profile actually looks like. If we want to drop the peaks a bit and just reshape the profile, we can do that here. And if we want to move the peak load, see here, peak 92% at 4 or 5 a.m. If we want to move it to say 5 or 6 a.m, we can do that, or we can bring it backwards. And that will adjust the load profile in the back. These are here as ways to represent, again, the load profile. So just showing you what the shape looks like. Now, when we get to the next part, we'll look at weather profile. So what it will ask you for is, do you want to look at this seasonally or just an annual average? So I mentioned before, we have seasonal profiles in there. If you look at those seasonally, it'll pick up seasonal weather, seasonal grid emissions, and seasonal grid pricing. Otherwise, it'll just work off an annual average, which is just an average of the seasons. So if we click seasonal, now we had a few attempts at trying to get this right, and one of the main things here is a simple way of determining when the building operates. We're not looking for a concept, even a concept design really. We're just looking at a good indication of what we're going to need with plus or minus 40% accuracy. So let's go for hours of operation, and we can basically click here and say, well, my building doesn't operate, it only operates on weekdays, and it operates from 9 to 6 p.m. So then I can basically apply that to just the weekdays, and I can turn off Saturday and Sunday. Or for example, I can go back and adjust just weekends and say, well, actually, no, I am open on a weekend, but only from 10 till maybe 4 p.m. or 2 p.m, let's say. And if I click that, it'll now reopen my facility. So what's going to happen is it's going to run the facility and the heating load requirements based on this operating profile. Once I'm done here, I can click next step, and it will ask me for an average heat required or an average flow required. Now, generally, you're going to want to know what the average heat is. The tip here is not to do a like-for-like installation. So even if you think you have 1,000 kilowatts or 1 megawatt of heating, and you think you really only run at 600 or 700 kilowatts, that's the number to put in here. Don't just go to the boiler and put the same capacity in. So let's just put 700 kilowatts as an example, and let's put a peak heating capacity of 1,000. If you're wondering where to find that peak, it can be a measured peak, you could have actual data, or you could actually just go to the nameplate of the equipment, and maybe someone from your service provider knows that only 1 boiler ever runs at a time, for example, rather than 2 running. So you could enter in, let's say you had 2 megawatts of boilers, you only ever ran 1. You could say, well, realistically, my peak is 1 megawatt. So that's how to get that number. There are some tips here as well. And if we see that, let's just make an example and say, well, we see that peak for 1 hour per day. And our supply hot water temperature, let's call that 70 degrees, and let's return the water at 60. So you can put any number you like in here. There are some general tips here. For every 10 degree reduction in heating temperature, your heat pump will generally be 2 to 3% more efficient. And if you're using CO2, the return temperature is best when it's below 30. So that's just a few tips there to guide you. Let's just put 70 and 60. This would be a fairly traditional heating loop, and I'm going to show you something in a minute on running scenarios. So if we have a fuel of natural gas, and our fuel cost is, let's call that $15 a gigajoule, and let's say I've got a nice mix of solar and grid power, and we've got a lower energy cost of say 12 cents a kilowatt hour. If you do know what your annual heating cost is from a bill, you can actually enter that in here. If the profile in the back and the calculations generate a close match to the number you enter, it'll run off your annual heating cost, plus or minus say 5%. If it doesn't, it's just going to run off what we calculate, because we need to do a like-for-like calculation. So we'll just leave that blank here, because let's pretend I don't know that. And I'm then going to ask you, okay, so what heat pump do you want? Let's pick air source, and let's choose propane. This is a good refrigerant for an aquatic center type application. And we're going to click next step. And it's going to ask you a question now about thermal storage. So basically what it's telling me when I first click this is the current minimum value for heating is 70%. Now, this is calculated from what we entered in the front section, which was 700 kilowatt average and 1,000 kilowatt peak. Basically what I'll do here, if I'm at 70, if I was to set this down to 60, you'll see here it's going to change. And now what it's going to do is it's going to increase your reliance on thermal storage. So it's going to say, well, actually I can let my heat pump size float down to 600 kilowatts. If I change this to 90, it's going to put more reliance on the heat pump and less on thermal storage. So part of the scenarios you can actually run here is changing these things around to go, actually I want a bit less thermal storage, or I want a bit more thermal storage. So we'll show you that again in a second, and we're going to just go back and set that at 70% because that's a good number. And we'll ask you then, do you want to do load flex or demand response? Now, already we've developed in the background an idea at this point of what the thermal storage for the system should look like, or just even a good water volume. Now, if you want to say, well, no, I specifically want to counter for 60 minutes where I can actually turn everything off and have enough water to run my facility, you can type 60 minutes in here. If you wanted to do it for 120 minutes, you could do that. If you wanted to do it for 10 minutes, you could do that. Or you can turn it off. Now, it won't double up. So if my base calculation says, a certain quantity of water, and you go and add another 90 minutes to that, and I already have enough water to do the 90 minutes, it's not going to add water. It'll only add, and let's say it calculates out higher, it's just going to add the difference, basically. So I'm just going to say no for the moment. And now we're presented with an output, which is an energy usage number, maximum electrical demand, and a heat pump size. So we said it's dropped it down to 696 kilowatts of heat pump capacity. It's picked up a full load CAP of 2, which is for Melbourne is actually quite low, but 70 degree water, it is going to drop that down. And it picked up a seasonal CAP of 3.41. It's going to give you CapEx, OpEx numbers. Very interestingly, you'll get these two sections, which are the spatial estimates for the heat pump. So basically, off supplier data, we were able to reverse engineer from a frame size and a typical length, an actual area, and a typical dimensions for what the plant would need. It does include spacing between the heat pumps, but obviously it's all at concept level. For thermal storage, it's calculated me out 31,525 litres. That'll take up about 20 square metres, and it's giving me a CapEx number. Now, let's not just assume that all these numbers are going to be totally accurate every time. I mean, we have to work off data we're given, but it will be pretty close. Now, if we have a look here, we'll see my simple payback doesn't look very good, right? I'm still saving money. It's taken me 18 years to get my money back. And because I'm not really, even here on my adjusted payback, I'm not really adjusting it well, even though I'm claiming energy certificates. So what's really cool about this section is we can actually just turn that off and say, well, we don't want to claim white certificates, and that box will just go away. But if we choose yes, we'll get a question of, are you using 100% green power or renewable energy? If we click yes, it's not going to change the certificate value, but it will show you what your emission savings are, and then it will show you what your emission savings were for the certificate calculation. So in effect, what this is doing is just showing you the gap between if you were or weren't buying green power. It's informative, it doesn't affect the calculation. It takes a certificate price and a certificate value and then deems that out. Now, again, this is representative. It's absolutely recommended, and there is a disclaimer here, to calculate that with a qualified organization, A2EP can help connect you to someone that can do that. Now, what's really cool about the tool is we can click this button and email my estimate, and it's going to email me things as I stand now. Equally cool is I can click back over to capacity and temperature, for example, and go, well, actually, that doesn't really look very good for a payback. What if I dropped my temperatures down from 70 and 60 to 60 and 50? And I leave everything else the same, and I click next steps. And now you can see my payback has improved. So here's how we're running scenario models in the tool, and we're getting a substantial lot more value out of our certificates. So before we were not adjusting the simple payback a lot. Now we're getting another year or so out of that and a whole lot more value out of our certificates. This gap is closing, basically. I can conversely do the same thing with thermal storage, and I can say, well, actually, no, I want to make my heat pump bigger, and click next step, and now it's going to change it again. Didn't change it much because the size is still going to be 696 kilowatts because it's still running the solver in the background to figure that out. There are some cases where that will change dramatically. And basically this is the summation of the tool. There are quite a few other things we could show or ways in which we could run scenario models, but for the most part, this is all pretty simple, and you can see how easy this is just to add load response to it and now increase my thermal storage volume, and it's modified my payback again. So what is to come in the future, there will be a whole array of other things added, but for the moment this represents a substantial change from what the base tool was. Integrates seasonal energy calculations, standardized load profiles, and it's also giving you a very good calculation and a very good indication of what white certificate value you will be able to claim for the project based on the emissions you reduce. So thank you.